In this section, we're going to be looking at how to test the significance of a correlation of R, and we're going to look at it testing it with a table of critical values. We'll see later that there's other ways of testing its significance, and you can choose the way that you think is the easiest. Now, let's start off with a statistic that I collected in a class, and it was 27 people, and the correlation between shoe size and extraversion was minus 0.254. So extraversion is how talkative, how social, how outgoing, how dominant somebody is. And we had a negative correlation between shoe size and extraversion. And it's negative, meaning that as the shoe size got larger, extraversion went down. That seems like a strange correlation. Why would people that have larger shoes be less extroverted? We could, if you're looking at the four causal relationships, we could say that shoe size causes extroversion. Yeah, probably not. Extroversion determines your shoe size. Yeah, I don't think so. Maybe there's a third factor that influences both, or maybe it's spurious. Spurious means that it's just happened by chance, and if we had a larger sample, if we looked at the whole population, it probably wouldn't exist. So I'm kind of leaning towards that spurious side of things. Now the question, we can formulate this question: can we be 95% sure that there is really a relationship between shoe size and extraversion? Or what does that mean? It means that the correlation doesn't equal zero. So we want to make a two-tailed hypothesis that the correlation doesn't equal zero, and that it's either really negative or really positive. And here we have a really negative, a negative correlation. We want to see if we can reject the idea that maybe it is zero. So what we're going to do is we're going to look up the critical value of R in Pagano's textbook. It's called Table E, Critical Values of Pearson R. So that's what this looks like. I'll show you this here. This is the table of critical values of R. And in order to use this, we need to look up the degrees of freedom, and we'll talk about that. We need to know if it's a one-tailed test or a two-tailed test, and then the significance level. Now, if you're using a table of critical values, I'm pretty sure you'll always use p equals 0.05, but if you wanted to use something else, you could, and the values are given here. So let's talk about this degrees of freedom. In correlation, degrees of freedom is a way of describing the exact shape of a probability distribution. It's really technical. There's a lot of math involved, but we constantly need to be able to test degrees of freedom when we need to know the degrees of freedom when we test for significance. Now, with correlations and in most things, the degrees of freedom is the sample size minus the number of means that we calculate. Now, with correlations, we've got two variables, and we tend to calculate the mean for both of them when we need to calculate the mean for both of them when we calculate the correlation. So the degrees of freedom, anytime that we have a correlation of two values, is n minus 2. So let's go back here. And so the degrees of freedom, called df, is n minus the number of distributions that we have, the number of distributions that we calculated the means for. And so we've got shoe size and extraversion, so that's 2. So it's n minus 2, so the degrees of freedom equals 27 minus 2 equals 25. Now we're making a two-tailed hypothesis. We want to be sure that we don't have theoretical reason that correlation should go in one direction or another. So with these two numbers, the degrees of freedom equals 25 and alpha equals 0.05. We're going to choose that as our alpha level. It's two tails. We can go to the table here, And we have degrees of freedom equals 25, so it's this line here. And we're using a two-tailed test, so we're going to use alpha equals 0.05 here. And so we get the number 0.3809. So 0.3809 is our R critical. And so that means that with a sample size of this size, significant, if the absolute value of the correlation is higher than this R crit, then we can be pretty sure it's not spurious. But in our case, the absolute value is 0.254, which is less than R crit. So the absolute value of R is less than R crit. So we retain the null hypothesis. The correlation is perhaps spurious. Oh, so maybe this is just an error that came from having a small sample size. We'd have to keep on testing to be more sure to see if there really is a correlation there. But maybe there isn't a correlation between shoe size and extraversion. So we have to retain the null hypothesis that there's no relationship between shoe size and extraversion. So that's how to use the table of critical values of R. You can Google table of critical values of R and you'll find this. That sometimes, even though I have this textbook constantly on my desk, sometimes I do that just because it's easier. Now let's see how we could use this in a couple other examples. Here's some more student correlations that I've collected. Now, in this one, it says among 62 stat students, the correlation between Christian commitment and extraversion is minus 0.014. So I teach at Azusa Pacific, and we're a Christian university. And one of the things that the school values is this personal commitment to Jesus Christ. And so I did a study where I measured Christian commitment and a few other variables. So here I compared Christian commitment to extraversion. It's minus 0.014. So the question is this a significant correlation using alpha equals two tails? So what we need to do is we've got a two-tailed test here. Alpha equals 0.05. That means we can be wrong 5% of the time, and we need to communicate that we know we can be wrong 5% of the time. We have 62 students, so the degrees of freedom is n minus 2 would be 60 students. So let's find what the critical R is for 60 students with a two-tailed test and alpha 0.05. So going down here, we've got 60 students down at the bottom, and we've got alpha equals 0.05 two-tailed, and we need to have a correlation of 0.250 for it to be significant. Now, what did we have? We had 0.05, minus 0.014, which is really small. So the absolute value is like 0.01, and we needed 0.25. So we have to retain the null hypothesis that there's no relationship between Christian commitment and extraversion. Now, does this prove that there's a no relationship? No, not at all. It just means that we don't have evidence that there is one. We don't have strong evidence. Perhaps there is if we measured everybody in the world, maybe it would be minus 0.004 or plus 0.025, some small correlation, but we didn't find evidence with this small sample that we had that such a correlation exists. Now, the second example here is that it's in the same group, so that's 62 students. Degrees of freedom would be equal n minus 2, so that'd be 62 minus 2 equals 60. The correlation between gender, where we would assign numbers to the two genders, 0 equals male, 1 equals female, but we could have had other direction also, but we need to keep track of the direction so we can know what the positive and minus sign means. So the correlation between gender and shoe size is minus 0.628. So does that mean that men or women had smaller shoes? Well, it's the low number is male and the high number is male. So you can kind of do the logic. The more you become female, the smaller your shoe size is. That means females have the smaller shoe size given the negative correlation, which is good news because that's probably what everybody would have guessed also there. So now, is this a significant correlation using our alpha equals 0.05 two-tails test? Remember, this was, we had 62 students, so this is the same as before. Whoops, we go to the degrees of freedom equals n minus 2, so that's 62 minus 2 equals 60. And we go over here to to the two-tailed 0.05, and it's 0.250. And oops, and so here we are at our example. So the absolute value of minus 0.628 is 0.628. So that's larger than 0.25. Yes, this is a significant correlation. We can be 95% sure that guys, the average shoe size for guys is larger than the average shoe size for girls.